Never start writing the code without explaining to the interviewer. All right. So, are you familiar with dynamic programming?
Yes.
Cool. So, the next question that I have for you is related to that. I've pasted the question in the column for the questions. Try and go through that. Okay. Were you able to understand the question?
Yes.
Hmm.
Like I've found out, I can choose any of the elements in any order. I mean, from anywhere.
Correct.
Okay.
So in this case, your two shares could be, so you can have six here. Let's say you have five, maybe three here, and this, now this is eight and eight. So your output would be one. This is one possible solution. That this is how you'd separate the shares, and the difference would be one because this totals up to nine and this is eight.
Okay. Yes.
Okay, how would you approach this?
Like the simplest, I need to use the whole set in this case.
Yes,
Okay. So like one simple way is choose create all the subsets and compare each subset with the sum of that subset with the remaining elements, some,
hmm.
and check the difference, but that would take a lot of, that would have a high time complexity. So
What would be the time complexity of that solution?
o to the power n, o to the power n dot n, I think. Yeah.
Okay, n square you mean?
No, n dot to the power n, like n for iterating to the list and to the power
Hmm.
n for creating those subsets.
Okay,
And another way is like these elements, we can like use somewhat the knapsack logic in this question and check what sums can be created, uh,
correct.
what sums are possible, and we can store those sums basically and just, but however, like, yeah, after checking one particular sum, and we can calculate the total sum, and for each smaller sum we can difference, like I'm not able to explain you.
It's okay. Okay, so you are thinking in the correct direction. This is very similar to zero one knapsack. Okay, now tell me in zero one knapsack, what do you have in the input? You have two arrays or two sets, right? One is for the weight and another one is for the value of the items, correct?
Yes,
Okay. And what is the target of the zero one knapsack? What is the target sum?
target sum is the like maximum sum which we can like achieve through the number of, while maximizing the number of elements.
Correct. So your target is maximum weight that the knapsack
Yeah.
can hold, correct?
Yes.
So here, what would be the target?
Here, like minimizing the difference, like
Hmm.
the it should be closest to the up, like how do I explain it? Like whatever sums we get,
Hmm.
it should be the n, like let's say the total sum and we have sum. The total sum minus sum of I should be minimum. Like should be as close as possible to sum itself. So
Correct. So The person here wants to divide his shares equally, right? So what is the best case scenario? That both the sons get equal value of shares.
Yes.
So what would be the target sum for one of the partitions? It would be sum of all these elements divided by 2,
Yes. Okay.
correct?
Yes.
Okay, and what are the weights and the values here?
Like these are the weights,
Okay, and what are the
and
values?
values are not like one value. I don't think values would be needed.
Okay,
Like, can I write the function because like I can maybe explain better with it.
sure, go ahead.
Okay. So first, like I'm finding the total sum.
Correct.
Then the target values would be sum by 2.
Hmm.
So I would declare let's say in an array with this this size target plus 1, and then would start iterating.
Okay. Do you think a 1D array is sufficient?
Yes, I uh, for this question I think 1D I can do it with one dimension.
Okay.
So I'll go through each of the elements and check if the DP first if I minus if right now if I minus array of j is greater than equal to 0, and then DP I minus array j equals 1. So this sum would also be possible. DP of DP I equals 1, and like I can store this like int answer equals 0. So for each of the possible sums, this as this I is increasing, so the possible answer would also increase at each step. So I can just simply update this answer
Okay.
equals I, and so finally this would be I equal I less than equals target. This should be as close to sum by 2 as possible. So what I can just return the answer as the difference absolute value of sum total sum minus this is the bigger one, and this is the answer minus something like this.
Okay.
So yeah, I think one-dimensional array should work in this case because we don't need the value count. We just need to check the difference, what maximum difference, and for that we only need to see what maximum sum can be made.
Okay. Let's try doing a dry run for this. Okay.
Okay, so 62153.
Hmm.
So first, sum 0 minus 6 won't be there. For 0, there won't be anything. For 1, when I equals 1,
Okay.
uh,
Not like this. You don't do a dry run verbally. Whenever you're doing a dry run in the interview, try typing what you're doing. Okay.
okay, so for I equals 0, I need to initialize this. dp 0 equals 1.
Hmm.
And for I equals 0, like the maximum answer would be 0 only. dp 0 equals 1. Oh yeah, 0. So for I equals 1, we have got the element 1 in the array. So the sum 1 is also possible. So answer would be then like the new answer would be 1. And for I equals 2, since 2 is present, the new answer should be 2. And similarly, I equals 3, 3 is present, so the new answer would be 3. And I equals 4, 4 minus 1, 3 is present, so 4 would be the new answer. And the total sum is 8, 9, 14, 17. So this should go till 8. I less than equals to 8. Okay, so I net total sum equals 17.
Hmm.
So target equals 8. So this outer loop would run 8 times. So for I equals 5, 5 is present. So the new answer would be 5. Uh, for I equals 6, yeah, 6 is also present. So the new one would be 6. And I equals 7, 7 minus 1, 6 is present. So the new answer would be 7. For 8 also, like 8 is present. So the new answer would be 8. And so the final answer would be sum minus answer, which is the answer is currently I got by iterating the whole loop is 8. And so this is the sum of the first partition. The sum of the second partition would be 17 minus 8, which is 9, and their absolute difference would be 1. So 9 minus 8.
Okay. All right. And I can see that in the dry run, you just considered the iterations for I. What are you doing in the J loop?
Yeah, for J, I'm just checking I minus array j. Like, okay, so I'll take I equals, for example, for I equals 4. So
Hmm.
first J would be J, first J would, array of J would be array of 0. If for array of 0, I'm checking if 4 minus 6 is greater than equal 0. It is not greater than equal 0. So that means there isn't a sum present which includes 6 and is equal to 4.
Hmm.
So, and then let's say I've come to 2. So, 4 minus 2 greater than equal 0, yes. And dp of, uh, okay, I think, yeah, I committed a mistake there. So, these are not exclusive. I would need another dimension then. dp of,
Right. That is what I was pointing to initially. So you missed one small thing here. These are not just the weights, but these are also the values in this case.
yes, okay. So, I, or in j equals 0, uh, this shouldn't be,
Okay, so initially on line 51, you have said dp of ij will be equal to 1. Now just think what two options do you have? For each element of the array, it can either come in the solution or it cannot be in the solution. And we have to choose the maximum one of those two, right? The one which creates the maximum value.
yes,
And that is what we will store in dp of ij.
okay. So, either it's the same PPIJ or the previous value plus, plus the current value. So,
Right, which would be array of j.
answer, so I don't think so. Answer would be here. Uh, then, okay, PPIJ minus 1 or, yeah.
Okay. And what would be the answer now?
So, answer should be the maximum, uh, yes, RHS, so TP of target and n minus 1. This should be the answer.
Right. Okay. All right, I think we can end the interview now. I'll just share my feedback with you, and you can also share your feedback with me for me. All right, so you can stop sharing your screen if you want. Okay, so anything you think that I could have done better?
No, like you explained the questions properly, and like you also helped me whenever I was stuck. So
Okay, so my feedback for you is that first of all, I'm really glad that you were able to solve the questions. There are definitely some tiny mistakes in the code. I want you to copy paste the questions as well as the code that you've written and go through it again and find those tiny mistakes. All right. But
okay, yes,
overall, you've done very well in the interview. Just couple of key things that you need to remember when you actually go into the interview. First of all, never start writing the code without explaining to the interviewer what you are planning on doing. In fact, try and see if you can, do a dry run before even you start implementing the code. So in these cases, what you could have done is that let's say for the linked list question, you could have like you should have written what you were trying to do. Try to write a pseudo code kind of thing, not too much detail, but just a little bit so that you and both the interviewer understand what exactly you are planning to implement. This would also help you in implementing the code while you're writing it. Okay,
okay,
that is one thing. Another very important thing to note is always handle the corner cases because this is what the interviewer will bother you about. So, for instance, for the linked list question, these
yes,
tiny things, the simple checks that what if root node is null, what would you do then? What if the value of k is greater than n, although that was specified as a constraint in the question? So you can skip that, and try and ask more clarification questions if you need. In this case, I saw that you asked one or two questions, but you were pretty clear on them. So that is good. Just remember these two, three things, and you should be good.
okay.
All right. So it was great interviewing you, Aryan. Thank you so much.
Thank you.